Welcome back. This video is actually the fifth in a series of Git videos that I'm making for this channel. If you haven't already seen the previous 4 videos, I'd recommend watching those beforehand in order to fully understand the topic that we're going to cover in today's video. Enjoy! Ha! See? I got you. You thought I was going to yell out Git. It turns out I... Git! This is another video for the Git mini-series for my channel, in order to help you fully understand Git and how to properly use it. In the previous 4 videos, we've covered everything from the basics, setting up a Git repository, cloning down a repository that already exists, branches, merging, and in the previous video, we talked about Git remote and actually uploading your changes to the server using the command git push. Just an FYI, we are using GitHub as our online Git repository. So far, we've not had to actually interact with any other users in our Git repository, which is unusual because Git was created to help teams work collaboratively on one project. That's one of the big benefits of it. So today we're going to see what the first interactions with another user on our repository might look like and actually pull down another user's changes to our code. If you hadn't already guessed it, today's video, we're going to talk about Git Fetch and Git Pull. Let's get into it. Hi there folks, my name is Ben and welcome back to the channel. As usual, consider hitting that subscribe button if you like what I do on this channel. And don't forget to hit that thumbs up icon if you enjoy this video and the rest of the Git mini-series. So let's just remind ourselves about the analogy that we're using for the Git ecosystem. Here's the terribly stupid analogy that I've given you in the past, which is you are, as the developers, the kids working in the kitchen on cookies, the code changes. You take your changes from the working directory to the staging area to the cookie basket. When you're happy with your cookies in the cookie basket, you commit it underneath the Christmas tree, which is like locked into your local Git repository on your machine. Finally, when you're happy to upload your changes to the server, you push your basket of cookies, your collection of basket of cookies from underneath the tree to the arms of your mother, who acts as the remote Git repository, the server Git repository. This flow highlights one user's journey through Git and getting from 0 to changes all the way up in the server for other people to access. However, it doesn't show how we actually maybe go to our remote Git repository, our mother, and take baskets of cookies down. If you remember this video from the previous episodes, this is a really nice diagram to show you the flow of Git as things are changing. Obviously, here is one developer, developer A's computer, and developer B's over here. Developer A moving their changes all the way from the working copy staging area to the local repository using git push from the last video to push it to the remote repository. And today, I want to look at how we actually take code from that server and bring it down to our own machines. Of course, we've looked at, in the very first video, the Git Clone command, which takes a repository entirely and copies it, clones it down onto your local machine for you to make changes with. And that's fine, but that's only in the circumstance that you are a brand new developer joining into this repository for the very first time. Once you've taken part in that Git repository for a while, you can't just git clone to clone down the whole repository again. You have to use different commands to update certain areas of that repository. And that's where these 2 commands here, pull and fetch, come into the picture. To put it into very oversimplified terms, the git fetch and the git pull command do updating for your local repository. Those commands ask the server, hey, what's changed? And take down the changes onto your machine again. So let's just remind ourselves where we are in this repository. If I do a git log like we did before, I've got multiple commits. The most recent one is I added a line, hooray. I've got these files, ABC and notes, and I'm in the branch master. And of course we had other branches from the other videos. What I'm gonna do now is I'm gonna pretend to be another user entirely, okay? I've actually got a space here on the right where I'm running inside of a completely isolated environment. For anyone that's interested, I'm running inside of a Docker container that has access to Git, okay? So I'll put something on the screen to let you know which side is which, but on the left is the Cardelio user. That's where the user that's using my local machine, the one that I've been in the other videos that's done all the changes and uploaded to the server, okay? However, the one on the right will be this other user, this different user completely that will be making changes to our code base and uploading them First things first, I would like to introduce you to the other user that I'm going to pretend to be today. That is, of course, Ken Bedell. He has his own GitHub account as well. He hasn't done anything at all because I just set it up for this video. But we're going to get him involved with our projects. As I said in a previous video, the third-party online repository providers like GitHub, Bitbucket, GitLab, etc., they do actual contribution with other people, with other users in different ways. And I talked about how GitHub does this sort of forking thing. So if I wanted to change a repository over there, I would fork it, I'd do my stuff, and then I'd ask for it to be brought in over there. However, in most of these third-party providers, you can actually, as the owner of the repository, say, hey, yes, this user over there, I trust them, they can just sort of already have permission to make changes to the repository. And we can act as already as a sort of team, and he can make changes, I can make changes, I can pull down his and he can pull down mine, so on. We can act although as ready as we know each other. So as Cardelio, as the administrator of the account, I'm going to go to the settings tab on GitHub, and this will be different on different third-party providers. I'm not giving you a tutorial on that. I'm going to go to manage access tab, and I'm going to go to the bottom, invite a collaborator. Basically what I'm going to do is I'm going to skip all of the nonsense, and I'm just going to invite Ken Bedell to be a full-on collaborator. So I'm going to put in his username in there, I'm going to invite collaborator, and I'm going to add him to the Git series repository. An email has been sent to Ken Bedell's email address that's attached to the GitHub, and Ken Bedell, of course, has gone and confirmed it. So if we refresh this page now, you should see that I accepted the invitation on Ken Bedell's email, and he is now a collaborator on this repository, meaning that he has write access, he has push access. Obviously on GitHub, everyone has sort of read access on these public repositories, but no one has write access except for the administrator. Now I've added a collaborator. Basically, someone else can push to this repository. That someone else is Ken Bedell. So the first thing that Ken Bedell would do, if we are looking at if we're looking at GitHub, like Ken Bedell would, he would do the Git Clone process to start with, to copy down the repository to his machine. You've seen this in episode 1, so I'm just going to copy the URL of the repository, going to go onto his machine, I'm going to do Git Clone and put the URL in there. Of course, the URL is the exact same one. It's the same repository that Cardelio made, so it's Cardelio, the owner, /git_series. Going to hit enter, it's going to clone the repository, I'm going to clear the screen, and I'm going to look at the folders. I've got the folder there, I'm going to move into it, CD, change directory into it, and I'm going to look at what we've got. We've got ABC text and we've got notes text, same as on the actual physical machine that started the code. And I'm going to do a quick git log as well to see that we're in the master branch and we have these other commits that Cardelio did, okay? So now the fun bit, I'm going to make a change as Ken Bedell, and I'm going to upload it to the server, and I'm going to get Cardelio, Ben, on the other side to download it and see what happens, right? So I'm going to just use vi to open the ABC text file, and I'm going to add a new line, this new line by Ken, okay? I'm going to save the file, and just as we did in all the previous videos, Ken has got the exact same flow of Git moving through the working directory, the kitchen, to the cookie basket, the staging area, and committing underneath the Christmas tree. So if I do git status now, you can see the abc.txt was modified. I'm going to do git add dot to say add all the cookies. Now if I do git status again, you can see that the changes to abc.txt have been added to the staging area, to the cookie basket, ready to be committed. If I did git commit now, okay, I get the warning that we might have seen back in the first video that Git says, hey, I don't know which user you are, like which user. You haven't set up your user email or your user name. So what I'm going to do now is set up the user email and username that Git is recommending with these two lines of code, very simply, and I'm going to set up Ken Bedell. Enter, done. Right, now I can do git commit, okay, and it's happy now that it knows which user I am. I'm going to, of course, add my commit message. This commit is from Ken B, okay? Save the commit, and it is committed. Let me just clear the screen. It's a mess. It's all green as well. It's not colorized because it's not my proper computer. But let's just do git log -- one line, and we can see right at the top is the commit from Ken right at the top, which is the commit from Ken. Okay, I'm going to just very quickly, just for full clarity, I'm going to go over to my computer on the left. I'm going to clear the screen and I'm going to do git log, just again to prove the last commit. In fact, I'm going to do git log --1 line to prove that the commit from Ken isn't on my machine yet. Of course it isn't on my machine yet. Let's go back over to Ken, and because Ken now has push access, because he is a contributor of this repository, he's going to now just upload his changes. He's going to push using the commands that we used in episode 4, in the last episode, to push his commit to the server, to push his cookie baskets from underneath the Christmas tree where they currently are committed into the arms of his mother and my mother. Weird. So git push origin master. Now, because this is the first time that I'm pushing, it's going to ask me for my GitHub credentials. This computer, this Docker container, hasn't saved any of my credentials yet. Okay, so I'm going to be using the credentials of Ken Bedell as well. So the username, Ken Bedell, and the password, I'm going to type in my password. Boom. Hopefully that's right. It is right. It's correct. It is now performing the push, and it says, as we learned in the last episode, that the push has happened. It has updated master. Great. So let's jump over to GitHub really quickly and let's see from Cardelio's point of view Ken's changes. So you can see that the commits was 11, it's now 12. If I click on the commits, we can see that the last commit from Ken is on the server and it's there for the branch master. So I'm just going to clear Ken's screen and I'm going to shift it over to the side a little bit. We're not super interested in that anymore because now I want to see what happens, how Cardelio, how normal Ben gets the changes from the server that Ken made. All of the stuff that we did with Ken was just what we've learned in the other episodes. Now's the new stuff. We're going to use the Git Pull command, okay? You can imagine, if you like the analogy, the Git Pull command is your mother coming down the path and giving you some cookies. You're pulling them into your home, into your house, and enjoying them underneath the Christmas tree as well. You're taking all of the things that your mother, the online repository, has and bringing them into your code bases, into your branches, okay? So if I just use the command git pull and telling it the first argument is origin, so where I want to pull from, which server. Remember, origin is just a nickname that Git has given to our server, so we don't have to use the full URL. And then the branch that I want to pull down, which is master. So I want to do git pull from the server, please, from origin, the branch master. Let's hit enter and let's see what happens. Cool. So it has performed the pull, okay? And what we can see here, it's telling us some information. It is telling us it's doing updating and fast forward. Fast forward's really interesting. If you watched the merge video, which I believe is video 3, you'll know what this fast forward thing is. It's merging in the changes that it got from the server, and because there's nothing to conflict with it, there's no changes here, and it's just about fast forwarding in time, it's just about updating, it's performing a fast forward merge. Again, if that confuses you, go to the merge video, links somewhere here to understand that fully, because it makes more sense when you've seen that video. But for all intents and purposes, our local branch of master has fast forwarded. It's updated now because we used the pull command, which pulls in the changes from the server. So let's see that. Let's use the git log -- one line command, and we can see right at the top this merry little commit at the top. This commit is from Ken B. Okay, let's just do a full git log here, and you can see the second one down is the last commit that we had on our machine, and the top one is the commit from Ken B with the author, Ken B, and his email address and timestamp and the commit ID. But that's interesting then. What actually is Git Pull doing? And that's a really good question. Git Pull actually is doing two commands at once. Git Pull first runs a Git Fetch command. Okay, it runs a Git Fetch command. After it has completed the Git Fetch command, it runs a Git Merge command. To explain it sort of with the complicated version overall, it runs a Git Fetch command to update your remote tracking branches of the repositories of the server, okay? And then it uses the Git Merge command to merge your remote tracking branch version of the branch into your local version of the branch. Don't worry at all if that has confused you. It may sound weird and complicated, but I'm going to explain it now. Let's start with the latter one first. Git Merge we actually covered in video 3. So video 3, and it basically combines two versions of branches to each other. It merges the changes together to form a new bit of history. However, this Git Fetch is the important one, okay? What is Git Merge? What is it actually merging into? From what into what? What's it merging together? Okay, so I'm just going to siphon off a bit of this page and we're going to go and zoom in here to explain it. So on your local computer, okay, I'm going to draw a really rubbish computer, developer A, right? Okay. And over here we have developer B, blah, 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 and in the middle of them we have the GitHub cloud. Sorry about my cloud drawing. We've seen how A can push to the cloud and how B can push to the cloud. And then we did this pull command, okay? We did this this pull command. Let me just make the pen a little bit smaller. We did a pull command to take from the cloud, the version of the code, and stick it into our code. However, as we've just found out, pull does a fetch and then a merge. What is it fetching? So actually behind the scenes on your computer, you have two versions of branches. You have what I'm going to call the solid version of the branches. You have your checked out version of the branches. You have like master, feature, etc. But you also have something that you can't interact with directly. You can't see the code of, you can't see the files of any of this stuff. You can't interact with these bits. And these are the remote tracking branches. And I'm just going to draw them like dots just to sort of show that they're sort of there and not there. Okay. And these are the remote tracking branches. Git fetch. Okay. So a git fetch, I'm just going to draw a blue line here next to it and just point, what is that? That's a fetch. A git fetch goes to the server and it says, hey, what branches do you have on the server? Please give me the code of that, okay? And what git fetch is actually doing is what you imagine the git pull would be doing, the git update command, if you like. Git fetch is downloading the code from all the branches, from all the changes and all the updates into the remote tracking branches, okay? Into the remote tracking branches. So the remote tracking branches have, when you use git fetch, the most up-to-date version of master. It has the most up-to-date version of feature branches. It has all of the code in there, but you can't interact with that code directly. And that's a really important point. Git creates this sort of barrier between your actual physical, local, solid versions of the branches and the remote tracking branches. You do not have, once you do a git fetch, you do not have, let me cross that out there, that arrow, you don't have the actual physical code that you can interact with on your machine in your solid local branches, okay? They are just in the remote tracking branches. And that's where this git merge part comes in, okay? So the fetch updates your local tracking branch version of the branches, the up-to-date version, okay? The ones that you can't interact with. And the merge, okay, I'm just going to draw a box here for the solid, the fixed version of the branches on here. The merge is actually updating, is merging from the remote tracking branch into your local solid branch, if you like, your local version of the branch, okay? So a git pull does a git fetch to update the remote tracking branch version of the code. And then after it has done a git fetch, it does a git merge to merge in the changes that are on the remote tracking branch, the branch that you can't actually access. It's just like it's a tracker for Git to constantly keep up to date what's going on with the server when you use git fetch. And it merges in to your local branches the changes, the code. If you like, if it fits into the previous analogy, which is the cookies in the kitchen and stuff, you can imagine that the remote tracking branches are like the doorstep on the door, okay? And when you use a git pull, so a git pull, you're poking your head out the door, you're waving at mum, the remote server, and you're sort of telling her to download the changes into your house, into your Christmas trees, whatever. And she, because you're doing a git pull, is actually doing a git fetch and a git merge. She performs the git fetch, which is delivering the changes to your doorstep. You can imagine the remote tracking branches are your doorstep, if you like. They're there, the code is there, the change is there, but they're not actually inside the house yet. They're not under the tree. They're not integrated into your computer yet. They're not integrated into your branches. okay? And then a merge happens, okay? So you pick them up from the doorstep and you bring them inside and you stick them under the tree. I know it sounds incredibly weird and the technological side of it is probably a bit complicated, but just Git remote tracking branches. And in fact, if we use the command that we did in the past, git branch -a, you can see, and hopefully it makes a bit more sense, the green branches are the ones that are actually checked out locally on your machine, and the red ones are the remote tracking branches that your computer believes are on the server, okay? So if I just show you, if I do git branch -d conf to delete the branch conf, you can see it's already there, and if I do it now, okay, git branch -a, you can see that the local solid version of conf has gone from my computer. I deleted it, but the remote tracking branch, okay, that I can't particularly affect is still there. Okay, so I could still check out conf and bring it onto my computer. So there is conf there now, sort of locally on my machine, because the remote tracking branch was still there. So now as a test, let's just go back to GitHub, and I'm going to go to the branches option here to see all the branches inside of my Git repository on the server on GitHub. And I'm going to delete the conf branch, okay? So I'm going to delete the conf branch, and I'm going to go back to the main page here just to see, yeah, it's now down to 2 branches. Now I've deleted the branch, okay? We can still see it here on my remote tracking branch because I haven't used the git fetch command to update what my computer believes is happening in the server. I haven't updated my remote tracking branches. So if I do a git fetch here really quickly, you can see that it's still there. The remote tracking branch is still there because git fetch just takes new changes that have been added to the server. However, there is a git fetch with a -p command for a prune, and what -p will do is it will check what the remote tracking branches have now and what's not there on the server, and it will delete branches from your remote tracking branches that are no longer on the server. It's a nice way to clean out remote tracking branches knowledge of branches that have been and gone in the past. So if I do git fetch -p, you can see deleted the origin/conf remote tracking branch now, because I deleted it on the server on GitHub, and now I've used the git fetch with the -p flag to prune away any branches that don't exist anymore on the server. So if I do git branch -a, you can see now I just have the 2 remote tracking branches. So here's the git man page for the man page for git fetch. Let's just look for the word prune. Here you go, the -p. So before fetching, remove any remote tracking references that no longer exist on the remote. It is actually just a perfect explanation. Okay, let's do one more example just in case it was confusing. Okay, let's go back over to Kembedel over here. I'm going to clear the screen and I'm just going to do git log to see what the last thing was. Oh yeah, we're in the master branch and we did a change. Let me go into the notes file now, and right at the top of the notes file, I'm just going to add loads of nonsense letters, okay, from Kembedel. I'm going to save. I'm going to git add dot git commit and I'm going to second commit from Ken. I'm going to save, and I'm going to git push, origin master. Okay, it's uploaded the changes to master again. Let's clear the screen. Let's pop it over very quickly to GitHub just to see git series again, and we can see 13 commits now, and the top 2 are both from Ken with the mustache on. That is the second commit from Ken. Back to the terminal. Okay, and what I'm going to do now, last time I did a git pull, which, as we hopefully know, did a fetch to update my remote tracking branches. So it says, oh, hey, yeah, there was a change to master. Here's the actual code for it. It's in the remote tracking branches. It is not actually in the local branches. And then the pull, because it does a fetch, and then it does a merge. It merges the remote tracking branch version of that branch into the actual physical branch. But we can break that down into separate steps to sort of see what pull is really doing. So if I, over on Cordelio's side of the screen, do a git fetch, just a fetch, okay? Git fetch. You can see that it's going to give me a list of all of the branches that have updated, that have changed. And here it has updated saying, yeah, master has moved forward from this previous version that I knew about in my remote tracking branches to now this version that is new, and the server has updated me, okay? just to prove you, log --one line, I only ran the fetch, so I actually haven't got that commit in my local code repositories yet. The fetch just updated the remote tracking branch version of that. If I clear the screen, just git branch -a, the remote tracking branch, okay, can be referred to as whatever the branch is called with whatever the nickname of the server is called in front of it. So now I can do the second part of the pull, okay, so I did the git fetch part of the pull, so I'm going to do the merge part of the pull. So watch video 3 again for the merging, but git merge origin /master, okay, and this is what pull is doing behind the scenes. It does a fetch, and then it's doing this merge, which is merging into the actual branch master, the physical branch master on my local machine, the origin version, which is the remote tracking branch version. If I hit enter there, it does exactly the same thing that we saw previously when we did a full git pull. It is saying, yep, we've updated. It's fast forward and notes has changed 1. And let's now just do a git log --one line, can't spell. And you can see now the second commit from Ken has been brought in. So just to reiterate, what we've done this video, hopefully it makes some sort of sense, is we've shown this fetch and pull section of this diagram here. We did a pull, okay? We had another user, Ken, who did some changes to the server, to the master branch. We did a pull, okay, which basically updated our machine's version of the code based on what's on the server. However, we learned a bit deeper. The pull actually consists of 2 commands, one after the other. The git fetch command, which updates our computer's remote tracking branch information. So it actually brings the code down, but not into our versions of the branches. And then the second part of the pull command does a merge, and it merges the remote tracking branch version of the branch into our local branch. Okay? And we just saw in the last step there, I sort of performed a git pull by doing each step individually to prove to you what the git pull is really doing. And that's it. In this video, we stepped it up a notch. Thanks again for watching, and don't forget to hit that subscribe button if you enjoyed this and of course the series as a whole. And of course, hit that bell icon if you want to be notified as I release new videos. If you have any questions at all, and you may have loads, please, I beg of you, reach out to me at my Twitter handle @Ben_Cadell. I'm happy to help anyone that's got any sort of Git problems. Hopefully I explained it in some way that is coherent and makes sense. And after all that, thank you so much for watching. See you next time. No, this is stupid. I hate it. Okay. Am I recording the screen? Yes. 7 minutes just for the intro. Crap.